morning, welcome back to grade 9 mathematics. I'm back, to explain to you guys about our topic today. Our topic today is going to be recognizing graphs of quadratic functions. Okay, so our previous we were transforming standard form to vertex form, but for today we're going to look at the graph and how it's going to be shaped. So if you recognize a while ago, we were talking about the U-shape. So what is the name of the U-shape? The U-shape is called a parabola. In the quadratic function, this U-shape of function is going to be called parabola. And then the parabola will either open, like what examples I was discussing to you a while ago, is going to be, it's either facing upwards or it's going to be facing downwards. So key things that we need to know, if A in the standard form, of the function is going to be greater than 0, that means it's going to open upwards. It's upwards. But if A in this equation is going to be less than 0, so meaning it's going to have a negative number. It's going to have a negative number. It's going to be opening downwards. These are key things that we need to identify. If A is, like example, positive 1, positive 2, positive 3, positive 4, positive 5, etc., it's going to open upwards, while if it's negative, it's going to be opening downwards. That is an important thing we need to take note. So now let's look at the graph. Let's look at the graph. As we can see that the graph is opening upwards, right? So we know that A's value is greater than 0. But let's talk about the parts of the graph. So there are multiple parts in a parabola that we need to take note of. But first, let's talk about the first form, about the vertex. So, if you remember why we talk about vertex forms, because we need to identify what are the coordinates where it will change its value. So, for example, if it's going downwards here, it changes value going up from this point, and that's what we call the vertex. That single corner point, that corner point is called the vertex. Now, the other parts that we need to take note of are the X-Intercepts and Y-Intercepts. What do we mean by X-Intercepts and Y-Intercepts? It's when does the line in the graph passes through that X and Y line. So if we talk about the X-Intercept, it means that points that it passes through that line. So when X becomes 0. So these are the 2 points. When Y becomes 0, when Y becomes 0. So these are the 2 coordinates. This is what we call the X-Intercepts. Say X-Intercept. And then that point wherein if X is 0, that's what we call the Y-intercept. The line that touches the vertical line of the Cartesian plane. So this is the Y-intercept. Okay. Now, looking at this graph, we also need to take note of the axis of symmetry. Axis of symmetry is an imaginary line that we can draw in the middle of the graph. So it means if you're going to fold it in half, these 2 coordinates will always have a pair in the other side. So the left side has a pair in the right side. So the value here is equal to the value here for X. The value here will have an equal value here. The value here will have an equal value here. That's why we call this axis of symmetry. Because we will have symmetrical values from one side of the parabola to the other side of the parabola. So talking about looking at the graph, we need to also take note of these 2 terms, the domain and range. If you remember, if we're going to be talking about graphs, we always have to take note of domain and range. What is domain and range? So domain is all of the possible values X can have. So in this graph, all of the values for X is infinitely going negative, because the more it goes negative, the more it goes upwards, and the more it goes to the right side, the more it goes positive, the more it goes upwards. So the domain is going to be infinitely negative and infinitely positive. And this is true statement for all quadratic functions. So generally the domain is going to be infinitely negative and infinitely positive. So range now, that's where it changes, because range means all of the values possible for y. So what do we mean by that? So meaning all of the values possible for y is going to be the range. Now, if we look at this parabola, all of the values of y is only going to be at this point. And there is no values for y that is less than this. It has to be all above here. So that is where it varies. Now, y will only be greater than or equal to k when it opens upwards. Because k, remember when we talked about the vertex form, it's the point of y. If you're going to draw the domain, right? If you're going to draw the vertex, we have h and k. So this k value is the stopping point, the corner point for us to take note when we can say the range of this function. Okay, so so k is the range of this value. Will determine if it's opening upwards or downwards. If it's opening upwards, that means y is greater than or equal to k. If it's upwards. So what happens if it's downwards? So we just reverse the Pac-Man sign. So it's going to be facing the k. It's going to be less than k this time. If it's opening downwards, it's going to be less than k. So that means all of the y values is going to be only in the below values. So it cannot be greater than this. That's what we mean by it facing downwards. Okay, so we're going to take one example of this graph and let's try to analyze this graph. So we have the following questions that were posted in our learning kit. So let's try to answer them looking at the graph here. So for our first question, for what x values the graph increasing and decreasing? So if we're going to be looking at this shape of the parabola, in this shape, this values is going upwards here. So meaning if it's going upwards, it's in the increasing values, right? Increasing values. So the increasing values is when the numbers are less than 2. So for increasing values, it must be less than 2. So must be less than 2, right? It must be less than 2. Now for decreasing values, as we can see that the graph is going downwards from here on the point of 2, this is decreasing. So the values must be greater than 2. So the values must be greater than 2. So if x is greater than 2, it is decreasing in values. So as we look at the graph, so if x is less than 2, it is in an increasing shape. And if it's going to be from, and if it's from 2 going, if 2 is greater than x, so it's going to be in a decreasing fashion. So for vertex, if we're going to be talking about the vertex, like what I was saying before, the vertex is the corner point in the parabola. The corner point is this point, right? So we have a vertex of 2 and 4, positive 4. So it's written here and here. So this is our vertex, 2, positive 4. This is the coordinates of our vertex just by looking at our graph. Now let's go on for x-intercepts. So x-intercepts, as I was saying before, x-intercepts is the points or the points in the Cartesian plane that the graph touches the x line. So these are the 2 points that the graph touches the x line. We have 0, 0 and 0, 4. So our x-intercepts is 0, 0 and 0, 4. So 4, 0. 4, 0. Because the coordinate of 4, it touches on the x line. So for y-intercepts, there is no other points that the graph touches the y line, except the point of origin. So we also have the same y-intercept as the x-intercept, which is 0, 0. Coordinates, looking at the graph. So for axis of symmetry, so axis of symmetry is one line that we create as an imaginary line in the parabola. So remember the parabola's the shape, so the imaginary line will be here. So 2. So our axis of symmetry is x is equal to 2. So that is our axis of symmetry. Because that is where the values changes in shape or changes in direction. So reflection of y-intercept. So our y-intercept is 0, 0. So what is its reflection? Reflection is the value that is equal to it in the other side or the right side of the graph. So since the y value is in the left side, so what is the right side? So we have 4, 0. Now taking another value, so looking at our graph, if f is 5, so f of x is 5, so if x is 5, what value will it be in the graph? So let's draw that. So what should this point be? So imagining this point, the coordinates will be at 5, negative 5. So this is going to be negative 5. This is our answer. So how about the other question? What x values will make f of x is equal to 3? So what will be f of x is 3? So 3. So what points here? One is here and the other one is here. So these 2 points will give us a 3 for the f of x, which is 1 and 3. So x values can be 1 or 3, looking at the graph. And then for domain, as we said for a while ago, the domain is going to be infinitely negative and infinitely positive. So looking at our graph, remember our graph is facing downwards. So if it's facing downwards, what is the k value? The k value is 4. So we have 4. So if it's facing downwards, it's always going to be less than 4, right? It has to be less than 4. So that is our range. Our range is going to be less than or equal to 4 because it's facing downwards. So that is how we will be analyzing this graph. Okay, so let's take one more example before we wrap up this lesson. So this example is now facing upwards. So our previous example, our parabola was facing downwards, but this one is going to be facing upwards. So looking at this, we'll be answering the questions. So what x values in this curve is increasing? So what x values in this curve? So as we can see, its increasing pattern is looking at the right side. So it must be greater than negative 4. So if x is greater than negative 4, it has an increasing pattern or increasing values. But if x is going to be less than negative 4, as we can see, it's in a decreasing fashion. So it's going downwards, it's going here. So decrease. So we have these 2 answers for number 1. Now looking at the shape again for the parabola, we're going to be looking at its corner point. The point where it changes values is going to be at negative 4, right? So our value here for this vertex is negative 4. Now looking at here, coordinating it. So our coordinates is going to be negative 4, negative 4. That is our vertex. So our vertex is negative 4 and negative 4. How about for our x-intercept? So we have 2 x-intercepts here. The 2 x-intercepts is going to be at negative 6 and negative 2, right? So we have negative 6, 0, and negative 2, 0. These are the coordinates for our x-intercepts. So negative 6, 0, and negative 2, 0. For our y-intercepts now, our y-intercepts, so we just points over here. So we will be placing it at 0, 12. So our y-intercept is 0 and 12. So our axis of symmetry, so the middle point, so we have the x value of the vertex is our axis of symmetry. So x is equal to negative 4. So for the reflection of the y-intercept, so what value here is the reflection on the other side? So this is the right side of it. So what is the left side? So this is the left side. So we have the reflection in -8, 12. That is the reflection point of the y-intercept. So the reflection point of the y-intercept is -8, 12. So following now on the next question, number 7. If f of x is -8, which we identified from a previous question, if -8 is then 12. So that is our value. So f of -8 is 12. So what is the x value that will make f of x equal to 5? So what are the points that will give us 5? So the points that will give us 5 is over here. This is a 5. And then what is this coordinate over here? Right? So these two will give us 5. Right? So this is a -1. So possible answer would be x is equal to -1 or x is -7. So these two are possible answers for f of x is equal to 5. So our domain, again, our domain is all negative values of x and all positive values of x. So we will have the same equation as -infinity and +infinity. For our range, because it's opening upwards, we need to take note of the values that are going upwards. So it must be greater than -4. So our range is always going to be y is greater than or equal to -4. That is our range, because it cannot be less than -4, because that is not where the parabola is facing. So that's it for analyzing our graphs.